the tax to Europe. Europe will get the money for improvement of technology. We are at this point. Now, still our industrial people thinking about it. Why? Because during the first phase of approximation, EU approximation period, Turkey spent many effort to do it. But last 10 years, everything turned back. And nobody considered it. Now, we have a very big 40 years gap that we can solve that problem. This is the big issue. Now I will turn back. Which sectors at the first phase will influence that tax? Cement, iron and steel, aluminium, fertilizer, electricity. Why? Because they are emitting too much carbon dioxide. This is the way. Of course, it will continue, sorry. Of course, this is the first phase, and then they will add many sectors on it. And I don't want to talk about too much, but now before the eco-dengue, I would like to give little bit advice to you. Really, you should consider EU laws and legislation because it is not legal document. It is technical document. 90% is technical document. They give a chance to you to consider new system. If you consider it, you will be you will get help from that way. And also you should consider some economical issues. And now this was small story of the sustainability. Now just I will talk about little bit my firm. Yes. I don't know, maybe I can talk a little bit. My firm is not a big firm, small firm, at approximately 26 years old. And, but we made too much research and development project for EU. For that reason, maybe your professor found me. I don't know exactly. And we get very award from not only TÜBİTAK, but also European Union. But we follow some rules. We have some principles. And to take part in the project that have the approximate vision for the implementation of the action plan brought the EU law. We always use the approximation of the law. We made some research development project before, 10 years before, that we thought that it will implement in Turkey. This is our chance. And we apply EU engineering standards. We use EU funds. We know how can we use these funds. And we always follow the scientific baseline. Okay, now, you know, we have a Turkish firm and then UK firm established 2016. Then generally what we can do, we made some scientific things, let's say waste, but we use IT solution. Let's say we try to make green way that we follow. Now we interested in cities, building, architecture, industry, and environmental management. Yes, what we did, everything related with the sustainability. We never made except any project that, like an environmental impact assessment report, any pollutant industry. We didn't accept. We didn't do such things. We didn't grow, but we are still here. This is our goal. Yes. And it was not easy to use the research and innovation way because you are not getting money. But anyhow, we have very good engineers, and many of them went to abroad, and we are happy to work all together, our students, our professors, and young engineers. I don't want to go so details. We have clients, city decision maker, municipalities, mayors, industrial facilities. Nowadays, we are trying to finalize a very big project in Turkey, compliance with all industrial sector action plan. What we can do, we are, again, the help of the IT solution, we are making inventory for all sectors. Beneficiary is the Ministry of Environment, and we are trying to calculate their emissions and their needs for new changes to catch the EU standards and time. This is important. And also, we work very too much industrial organization. We finalized many projects, more than 30 countries, and we try to make some development also inside of the Ecodenge. We finalized such project. And you see, we have an ongoing project, Horizon project. UPA means integration, participation of the EU level, the government supportive project coming from, again, EU. We have some TÜBİTAK project also. We have consultancy. For example, CFA, CFA project. It was a UK project. We distributed UK funds in Turkey for decarbonization. They did not give the money to the government directly. By the way of some private sector, we try to help the people to prepare relevant projects and try to give the money for that purposes. Okay, you will see some keywords: sustainability and Green Deal, carbon accounting. Of course, we have some such small tools, and circularity. The most crucial thing is the life cycle assessment. This is important. We have, again, some tools. We have information, we have database, all best available techniques, reports, and the outputs, in income and outcome of the facility, not only gate to gate, but also cradle to grave. Then we are making such calculation for the new products, sometimes all products. Of course, climate change, we prepared many plan or something like that. Okay. I don't want to go too much. Just I would like to give some idea. You see environment and industry services. We made many symbioses, best available technique, circular economy, life cycle analysis and costing project. This is cities project. We made sustainable energy and climate action plan for the cities, energy planning simulation services with smart energy, smart city solution through ICT platform, and nature-based solution and urban circularity. We all, of course, we may at the beginning we worked on waste management subject too much. And buildings, we have many type of green buildings and other things, architecture. I don't want to go deeply. We have some product, of course, and thank you for you.
Dr. Yöntem, thank you very much for your speech. Now, please join me in welcoming our award-winning groups one by one on stage to perform their presentations on sustainability. Firstly, I would like to welcome Dilruba Sultan Haliloğlu, Kerem Fidan, İlknur Yılmaz, Kaan Keven, and Ece Teker on stage. The name of their presentation is Graphene-based solar cells in the context of responsible research and innovation.
Dear guests, welcome to our presentation. Today we will be talking about how innovating solar cells serves generating energy in more sustainable ways. We named our project Graphene-based solar cells in the context of responsible research and innovation. In our project, we interviewed 3 researchers from Istanbul Technical University Nanotechnology Center. And their goal is to produce graphene-based solar cells, which are more environment-friendly, less toxic, cheaper, and have higher ranges of wavelengths to absorb sunlight. And their work consists of 3 phases. The first phase is simulating the various combinations of graphene-based solar cells before their commercialization. They are doing this by utilizing machine learning algorithms. The second phase is synthesizing the solar cells. And the last and the third phase is fabrication of these solar cells into solar panels. So our goal in our project is to provide further information in this mentioned innovation and evaluate possible issues that lie at the intersection of its social and technical reflections. So, while examining the innovation endeavors of these researchers, we realized that developing a technology is a process where different stakeholders with different backgrounds meet. Thus, we decided to utilize responsible research and innovation theory. So RRR theory has 4 dimensions, and we think that the researchers' work has traces from all of these 4 dimensions. So I think no need to briefly explain each dimension, but for anticipation, they are making simulations and they are trying to decrease possible risks in the future associated with the technology. For inclusion, they considered the Turkey context into their research, and for reflexivity, they put environment as a value, and for responsiveness, they are trying to eliminate the toxic materials in these solar cells. The Ararat theory also has 6 lessons, as you all know, and we think that the researchers has 3 of them incorporated to their research. The first one is the broadening current assessments. So the researchers from Istanbul Technical University were mainly aiming to replace silicon-based nanomaterials with graphene-based nanomaterials. The second lesson is placing values into center stage. So the researchers put environment as a value in the center stage instead of the traditional considerations in this business like efficiency or durability. The third lesson is aiming for the shared values. So the researchers' goal, as I already mentioned, to have a sustainable, innovative product that serves the common values of the society.
So, as we mentioned before, 3 researchers, 3 professors from each nano lab kindly accepted our request to interview them. You can see Şener Hoca here. He works at the simulations part. And here we have Professor Levent, who works at the device assembly part. And we have Professor Caner, who works at the synthesis of the material part. And we interviewed them and transcribed our interviews and analyzed them through QDA MinerLite.
Now on to the technical aspects of the project. This project was done by an interdisciplinary team consisting of 4 science disciplines, which were chemistry, physics, electrical and electronics engineering, and mechanical engineering. Since this project was done by an interdisciplinary team, it consists of 4 main parts, first of which is the machine learning part. In this part, different configuration of graphene atoms were simulated, and since the number of combination of configurations were large, artificial intelligence and intelligent search algorithms were used to cut down on the simulation time. The second part was the graphene quantum dots part. In this part, the size and configuration of quantum dots were changed to alter the light absorbency attributes of graphene atoms. The third part was the doping process. In this part, graphene was doped with some non-carbon elements such as boron, sulfur, phosphorus, and nitrogen to increase the overall light absorbency efficiency. And the fourth and final part was the device implementation. In this part, all the previously done processes were turned into a single physical tool that could be utilized in the solar panel design.
There are many different applications for this project. The first one that could be mentioned is hot water. It could be used in residential houses, and it could be used to produce electricity in solar farms, and it could be used in many devices such as our cell phones, in our computers, and many medical devices where there is a chip involved. And it's very eco-friendly. It could be used in plants, and also it has many other different applications. But right now it's used for flat surfaces, but if it were to be developed further, it could be used for elastic surfaces as well.
And for the safety and risk part, we all know that today solar energy is more efficient and cleaner. But for the production and operating part, we see that solar cells are neither ecological nor safe. In line with information we received our interviews, we made on the project, they face 2 risks in the form of chemical, technological, economical, health and laboratory. For the chemical risk part, we see that avoiding heavy metals pop up first request, and that's why they use graphene for the solution. For the technical part, they talk about the software limitations, and they say that it comes with calculation problems for them. And for the economical risk part, they mentioned that excessive heat and energy because of the machines they used in the project caused a financial problem for them. And for the laboratory risk part, they talk about mainly the toxic gas problem. For the toxic gas problem, they use fume cupboards for the solution to neutralize and remove the toxic gas from the lab environment. And also for the chemical waste in laboratory, they use waste collection places for this problem. And finally, for the health risk, they mentioned that quantum dots that we criticized before, but they tell us what quantum dots in this scenario, and they support that there is no such thing for the quantum dots affect human health or animal health or problem for the environment.
When we come to the sustainability part, first and foremost, we see that they are developing a renewable energy source. So they are thinking about the environment aspect that was mentioned in the sustainable development or in the Brundtland report. And they're also using less toxic materials for their solar cells. So they're trying to make solar cells even a greener technology than it already is. And by using less toxic material, they are making solar panels, the disposal of solar cells more easier. And whenever there is a value conflict, like efficiency versus ecology or durability versus ecology, we see that they're choosing the ecology sides. For example, instead of using toxic materials to increase the efficiency, they are trying to use more eco-friendly materials like boron or nitrogen, and they continue to use carbon-based materials. And for the durability, even though the cells that they produce are less durable, they're trying to compensate with the economy part so that they can produce ecologically safe solar cells. And when we come to the society part, we see that they're also considering social sustainability. They're trying to make solar panels more accessible by making them cheap. This could also be an economic aspect as well as societal aspect, because they're trying to make people with less financial low financial situations to buy cheap solar panels as well. And moreover, they're trying to make Turkey less dependent, and they're thinking about the Turkish context. For example, they are using boron in their product, in the solar cells, because it's very abundant in Turkey, as you know. And they're trying to decrease the carbon emission by making Turkey less dependent to fossil fuels and oils. And when we come to the analysis and conclusion, we see that it's a good example of sustainable development, as I mentioned, because they think about the four aspects: society, environment, culture, and economy. And they also think about the 4 dimensions of RRI. For example, they anticipate the possible risks by, they think about the toxicity, they do simulations to decrease lab risks. And when we come to the inclusion, we see that they consider the Turkish context and they think about various stakeholders. And for the reflexivity part, they consider the environmental values, as we mentioned. And for the responsiveness, they use less toxic materials, so they're trying to make it more greener, as we mentioned before. And thank you for listening to us. These were our references.
Thank you very much for your presentation. The next group consists of Arda İçöz, Ahmet Melih Gıcır, Zeynep Selcan Öztunç, Erdem Deniz Erda, and Nurettin Onur Vural, and their project is titled AirCar, a Jetson's Dream Coming True.
Hi everyone, today we will introduce you a remarkable technological development that will redefine sustainable transportation, and the name of the technology is AirCar. So in this respect, AirCar comes out as a strong candidate to finally make the famous transportation style in the Jetsons come true. Here are the table of contents. So basically, AirCar is a flying autonomous transportation vehicle based on Istanbul, Turkey, and it aims to reduce the dependency on the general urban transportation system and reduce carbon emissions and create greener cities in this respect. So to analyze the technological development of AirCar, we used responsible research and innovation, and the key factors: inclusion, anticipation, reflexivity, and responsiveness.
For the method, we did interviews with the CSO, CEO, and an R&D engineer of the AirCar. Then we have coded these interviews using QDA minor light. And with these coded interviews, we found out some themes. These themes included themes like AI, costs, sustainability, safety, and privacy.
In the finding part, there are 10 different K values related to this concept. For the economy part, the main concern is about who drives these cars. AirCar is an autonomous flying car, therefore a pilot is not needed for that. Thus, it can use